So here we are back in Chapter 1, Part 2, the third task, where we need to configure OSPF routing in Data Center 1. So let's go through the routing part in Data Center 1, which is we need to establish an OSPF version 2 and OSPF version 3 between the four nodes, which is Virtual MX1, Virtual MX2, Core 1, and Core 2. For OSPF version 2, OSPF version 3, for OSPF version 1 and for OSPF version 2 and version 3, we need to advertise the loopbacks, and we need to have IRP VLAN 45 and VLAN 100 subnets. IP version 4 and IP version 6 subnets are all being advertised for inside the OSPF. OSPF version 2 and OSPF version 3 links should be set in the point-to-point mode. Then OSPF version 2, OSPF version 3 shouldn't be enabled on IRP interface VLAN 100. This means we can either have IRP interface 100 to be in a passive mode, or we can have a redistribution. We can configure a redistribution policy to redistribute the subnet of the IRP 100 inside OSPF. So we have either or. Both of them achieve the goal that OSPF is not enabled on the IRP interface. Then there is a requirement to ensure that the loss of link between virtual queue of X and virtual queue of X doesn't impact reachability. Actually, this third requirement is not so clear for me. I have reviewed the answer in the JNCIE data center self-study bundle, and there is no kind of special configuration to achieve such requirement, and I'll try while doing the configuration to clarify what happens if we lost the link between Q of X1 and Q of X2. Actually, in our setup here, if we lost this link, it will be actually a disaster either for data center 1 server 1 or data center 2 server 2. Actually, it will be losing the full connectivity towards the other server and towards the gateways. And I'll tell you why. We don't know exactly which server will be impacted, but at least one of them for sure, it will be totally isolated. One of the server totally isolated from the network if this link goes down. That's why I told you from the beginning, such a design is not the right design. We need to have data center, both the servers to be dual homed to Q of X's, because if this link goes down, we will see kind of a total isolation for one of these servers. So let's go and start the configuration for the OSPF. Okay, so here we need to enable the OSPF between the MXs and the core nodes, and between in the IRP interface 45 IRP interface. Actually, it is a back-to-back connectivity between the virtual MX1, virtual MX2, and the loopback interface for MX1, MX2, as well as the IRP 100 to be advertised inside OSPF but not enabled as OSPF. So let's go for virtual MX1 and start checking the configuration. Show interface loopback 0. So actually, virtual MX1 as a base configuration for this chapter, it's being assigned an IP address in the loopback, IP version 4 and IP version 6 in the loopback interface, as well as the interface 006 with a VLAN 46 is the interface that is used for connectivity between MX1 and Core 1. So this interface. So, and within we have two IRP interfaces, IRP interface 45, where we will enable OSPF in the back-to-back link, and IRP 100, where we will not enable OSPF. So let's enable OSPF version 2. So we need to configure interface XE006 we need to configure .46, and this interface mode will be point-to-point. Set interface loopback 0.0 in a passive mode. Set interface IRP.45 interface mode point-to-point, and then we left with the interface IRP 100. So I do prefer to actually to use the redistribution. Actually, here the requirement is saying OSPF version 2, OSPF version 3 shouldn't be enabled in IRP interface. As I mentioned, we can use either or to have OSPF passive interface for IRP 100, or to use redistribution. For me, to ensure 100% that this requirement is get achieved, so I'll use the redistribution, so I'll not even have the IRB interface 100 configured at all under the OSPF. So I'll use redistribution policy. So I'll configure it will be a single term redistribution. I'll just match in the interface itself. I'll use this routing policy. So under the configuration here, under the OSPF configuration, we have the back-to-back interface towards the core router. Core router 1 is being configured in the point-to-point, then loop back in the passive mode, then IRB 45, the back-to-back MX1, MX2, then we have a redistribution policy. Let's do the same for OSPF version 3. It will be actually, let's copy and paste the configuration. And take this configuration, then change it for MX number 2. For MX number 2, the interface will be a bit different, I believe, towards the core. So the interface towards the core is XE006.47. Let's go for MX number 2, interface XE006. So for interface 006 is been already configured. So let's just change this unit number to be 47 instead of 46, and the IRB interface will be the same. Then OSPF version 3, we need also to change the interface unit to be 47, and everything else will remain the same. So let's load the configuration using load batch. Let's commit here. So we assume the configuration in the core nodes are being already configured. We don't need to do any changes. We can check the configuration if there is any issues, but the configuration is ready in MX5, and we can also go through this configuration by the end of this chapter. Run show OSPF interfaces. So in OSPF, we have the loopback interface, and we have interface XE00646. So for some reasons, the IRB interface is not being displayed. So protocols OSPF, interface IRB here. Okay. So the interface IRB is not being displayed, and actually there is a kind of a mandatory configuration if we will be enabling OSPF under IRB interfaces. We need to have a static ARP binding between in each MX router towards the remote MX. So because there is some kind of issues happening in the IRB interfaces while enabling OSPF in the multicast, because OSPF is using multicast to discover the neighbors, and the IRB interfaces actually have some limitation with the OSPF multicasting. So for some reason we need to configure a static ARP in each MX towards the other MX under the IRB interface. So let's go here to edit interface IRB.45 family inet address 192. We need to have a static ARP towards 192.168.45.1 over the layer 2 interface AZ0, and the MAC address of the IRB show interface IRB45. We have configured the MAC address in a manual way, so we need to configure this MAC address here. Okay, and we'll do the same. I'm not sure if we need to do the same for IP version 6. Let's try. Okay, so let's do the same in the other side. So let's have this 2 lines. Okay, this will be applied in the other side. So we'll have in MX2, we need to have a static ARP towards MX1. Run show OSPF interfaces. Okay, still we have an issue for this IRP interfaces. So let me check the configuration. It seems for some reason I'm missing certain parameter. Okay, actually here the interface name is configured by mistake. Let me change the interface name. Okay, let's do the same for OSPF version 3 because I believe the same mistake should be there. Okay. So in OSPF version 3, we have the interfaces is being defined. Run show OSPF 3 interfaces. So we have IRP interface, run show OSPF neighbors. So in the OSPF version 2 neighbors, we have one neighbor in IRP 45, which is a back-to-back OSPF between MX1 and MX2, and we have another OSPF adjacency towards the core router. So actually configuring the static ARP that have been done, it's actually a kind of a recommendation. Maybe in the old Junos version, just for curiosity, I removed this static ARP. I believe after removing static ARP, the OSPF adjacency will remain up, but I know for old Junos versions, it is kind of mandatory to have this static ARP configuration because the OSPF is using the multicast 224.0.0.5 and 0.0.6. Actually, it is a point here, so it is only 224.0.0.5 multicast address that actually have some connectivity issue in multicast. OSPF multicast packets have connectivity issue over the IRP interfaces. But let me remove the static ARP and make sure that the OSPF will remain up. Let's clear. Let's clear OSPF as well from here. And then show OSPF interfaces. So if you see here, we cleared the OSPF neighborship between MX1 and MX2. Actually, we cleared all neighborship, and we can see that the IRP, the neighborship on the IRP interface is still up. So, however, the neighborship is up here, but I believe in the exam I'm running here kind of the newest version for the Q of X and the newest version for MX. I'm running here version 20.4. Okay, I'm running 20.2 in the MX, and I'm running version 20.2 in the Q of X. Actually, it is almost the newest version at the time of doing this lab setup. However, in the actual lab, in the actual JNCIE lab, I believe it will be running version 17 that you might facing an issue while establishing OSPF in the IRP interface. So now the OSPF getting established. Let's make sure as well OSPF version 3 is getting established. let's make sure that the loopback addresses from the core router have being advertised. Actually, the core routers, let's see what is the configuration in the core router or for the loopback interfaces. Actually, the core router number 1 is using loopback 005. Let's make sure, let's check what is the core 2 is using 006. So let's see the reachability for this range. So I check for all range 10.00/24. Okay, so from the MX1 point of view, we can reach 10.001, which is the local loopback of the MX. 10.002 is the loopback of MX2. 10.005 and 10.006 via OSPF, which is coming via OSPF towards the core node. Let's do the same in MX2. Okay, in MX2 we have also a full loopback reachability. Now as well we can make a connectivity check from the server sides towards the core nodes, because now we should have a full end-to-end reachability from the server to the core. So let's from data center 1. This is data center 1, server 2. Let's check 10.005. Okay, we have reachability 10.006. Let's check from server 1 as well, 10.006 and 10.005. Let's check as well the IP version 6. So the IP version 6. Okay. So let's try to reach the IP version 6 loopback address of core 1 and core 2 and MX1 and MX2 from server 1. From server 2 as well, let's do the same. So now we check the full reachability from server 1, server 2 towards the loopback address of MX1, loopback address of MX2, and the core loopback 1, core loopback 2, and this actually validates the requirement of the redistribution. We redistributed the IRB 100 inside the core. We can go in the core side and also validate this subnet, which is the IRB of 100. Now, if we need to connect to a logical system, now we are inside the logical system. So let's make show route protocol OSPF. For the actually the IRB 100 is holding subnet 192.168.1, and this subnet is being reachable by core 1 router via OSPF, and the admin distance or the route preference is 150. 150 is OSPF external route, which means this subnet is being advertised by MX1 and MX2 via OSPF redistribution. Let's go for core router 2. And do the same. Okay, and make sure the reachability for the 192.168.1 is being reachable towards the core 2, as well as the loopback of MX1, the loopback of MX2, and the loopback of the core 1. Now let's go to the last requirement, which is actually here, is saying ensure the loss of link between Q of X1, Q of X2 doesn't impact reachability. So what will happen in case we have this link goes down? When we have this link goes down, actually, because I don't configure status, if I don't, let me check if I configure status event in event of ICP goes down. So configuration interface AE1. Okay, so I don't configure the prefer status control active, neither here nor AE1 here. So I don't configure the prefer status control active. So in case we have this link goes down, there will be a case of split brain happen. So in a split brain, each one of Q of X1, Q of X2 will assume itself it is the only node inside the MC lag. So each one of Q of X1 and Q of X2 will roll back its system ID to the default chassis system ID. Let's test this scenario and see what will happen. just before we bring down the interface, let's make sure that from MX1, if we make show LACP interface extensive. So in LACP interface extensive AE1, okay, let's take from AE1. From AE1 point of view, here is my partners in interface 002 and 003. Both of the interfaces 002, 003 are using this system ID in the remote side, which is 0612. The same will be shown here, okay, where in X002 and 003, the partner is using this system ID. Okay, now when we bring down the interface between Q of X1, Q of X2, actually both of them will revert back to their own system, to their chassis local system ID. So let's bring down this interface and see what will happen. When we bring down this interface, the ICCP will go down. Okay, so ICCP goes down and a kind of a split brain situation will happen. Let's see from MX1 what will be the system ID. Okay, from the MX1 point of view, now if you see here the system ID, both of the system IDs of 002 actually is the interface connected to Q of X1, 003 is the interface connected to Q of X2. Now, if you see, these two numbers is being different now, because this is the default number. This is the actually MAC addresses, the default MAC addresses in MX1 and MX2. Now, in virtual MX1, virtual MX2 need only to select one of the Q of X's to maintain the aggregate Ethernet interface. So if we now show here, only one should be elected. One of these interfaces will be kicked out, because now system ID is different. Okay, so here is okay, looks just need few seconds for the LACP. Now, okay, so if you see here, the 003 interface is being detached. I just need to make sure it's being already detached. Okay, so it has been already detached from before, so that I just don't recognize it. It has been already detached. 003 is being detached, which is the the interfaces towards Q of X2 is being removed from the MC lag. It's being detached, and only the interface towards Q of X1 is being there. So from MX1, it only keeps this interface inside the multi-chassis lag. From MX2, it should be actually the same. So 003 will be remaining in the MC lag, while 002 will be kicked out. Okay, let's see on the MX2 side. Okay, here 002, which is the interface towards the Q of X2, is being removed from the virtual MX2, and only 003 is remaining in the MC lag. From Q of X1 side, we will see the LACP is both interfaces are still is still in the MC lag. Okay, so here in AE1, which is interface from Q of X1 towards the MXs, both interfaces 002, 003 is being collecting, distributing, and the remote system, the partners are using 0512 with 0512. Okay, in Q of X2, we'll find the aggregate Ethernet interface. Both interfaces are being detached. And show LACP interface AE1. Okay, now both interfaces are being detached, and AE1 will be down. Okay, so AE1 is fully down, which means this actually, when this interface is down, also Q of X1, the Q of X2 take this actually interface, these two links are being brought down because the ICCP goes down. So Q of X2 actually it changes the LACP system ID to its own local. Q of X1, it changes its system ID to its own local, and it will be a kind of a decision of virtual MX1 and 2 to select only one of these virtual FXs to maintain the MC lag. So now if we try to have a reachability from data center 1 server 2 to any ID, it will be fully isolated. Let's try this. So now I'm trying to ping from server 2 in the IP version 6. Let's try 192.168.1.1. So 1.1 only itself, it will be reachable, and then any other ID, it will be fully fully isolated. Requirement doesn't make sense for me, and as I have mentioned, under even the JNCIE study bundle, the self-study bundle book, there is no any configuration have been done to achieve such a requirement. Okay, so by this actually we have done for this task number 3.